So part C, we're asked to find the probability of a pregnancy lasting less than 250 days. So again, we're going to take this statement and translate it into a mathematical one. So again, we want the probability of something, so cap P parentheses for probability of, and we want the length of the pregnancy, which was our random variable x, to be less than 250, so to the left of 250. So again, we're going to draw a picture, remembering that, again, the center of this curve here is at 272. And so this probability that we're after, again, is the area of the shade, this tiny shaded left tail here. So to find the probability on the TI-84, looking at the picture, though it's hard to see in this case, the lower limit is negative infinity. Again, we cannot have a pregnancy that lasts negative infinity days, but again, the mathematical model curve that we're using to approximate these probabilities, that curve extends from negative infinity to infinity. Again, calculator doesn't have a negative infinity key, so we're going to use negative 10 to the 99th power as our close enough approximation to that. So again, reading here from left to right, our shaded region starts at negative infinity, so we enter in negative 10 to the 99th power, and it ends at 250, so our right endpoint here is 250, and then again the last two endpoints are the mean and standard deviation for this distribution. So we've got normal CDF, negative 10 to the 99th power, 250, 272, and 9. And again, if we push enter, we get 0.0072537738. And again, if we were to use StatCrunch, we would get that same exact result. So in this case, we've got the probability that x is less than 250. So that was our probability statement we started with. That is equal to normal CDF, negative 10 to the 99th power, comma 250, comma 272, comma 9, which rounded off, that is about 0.0073. So again, if we interpret that, there is about a 0.73% chance, so really small, chance that a randomly selected human pregnancy lasts less than 250 days. Or again, we could also say about 0.73% of all human pregnancies last less than 250 days as well. So for part D, we're asked to find the probability that a pregnancy lasts between 265 and 280 days. So again, first we're going to translate that statement into a mathematical one. So again, we want the probability of something, so P parentheses. So if we translate that into a mathematical statement, we would have the probability that x is between 265 and 280. And again, it just says between, it doesn't say between inclusive, so we're not going to put the endpoints here. But again, remember in the probability computation, we just leave this as 265 and 280. Okay, unlike in discrete random variables where we would rewrite these intervals to include an endpoint. But again, for continuous random variables, we're looking at area under a curve, and that does not change whether an endpoint is included or not. So again, now we're again going to draw a picture, keeping in mind that the center of this normal curve is at 272. So again, this right here, the center of that curve would be at 272 because that's where the mean of the distribution is. And in here we have shaded from 265 over to 280. So the probability we're after corresponds to this shaded area given here under the curve. All right, so in this case, our lower limit is 265. Okay, it doesn't extend out to infinity in either direction on our interval. So the lower limit is 265, and our upper limit is 280, and then our mean is still 272 and 9. So again, you should pause the video for a short second here and grab your calculator. And again, you should go into second vars to open up the distribution menu and choose option 2 for normal CDF and enter these 4 inputs of 265, 280, 272, and 9 to make sure that you get the same output that is displayed here on the screen. All right, so again, if we put all of this together, we're going to get the probability that x is between 265 and 280 is equal to normal CDF 265, 280, 272, 9. And if we round that value off that we got, it's about 0.595 or about 59.5%. So again, to interpret, we could say there is about a 59.5% chance that a randomly selected human pregnancy lasts between 265 and 280 days. Or again, we could say about 59.5% of all human pregnancies last between 265 and 280 days. So again, either interpretation is correct. All right, so now part E. Okay, so we've looked at several parts that we've been asked to find probabilities. And so if we have a normal distribution and we want to find a probability, we use normal CDF. But on part E, we're not asked to find a probability. We're asked to find the length of a pregnancy. Okay, so that's a value of x. And we're told that 10% of all pregnancies we want to last less than this amount. Okay, so this problem is asking you to find an x value, and we're given a probability or a percentage. Now, we want to find the x value that has 10% of the lengths of the pregnancies to the left of it, since we wanted less than. So on the TI-84, the command is in the distribution menu, but again, now we're going to use inverse norm instead of the normal distribution. Again, the normal distribution takes x values for an interval and computes probabilities. Okay, inverse norm basically inverses that, reverses that. So now, given a percentage, it's going to give us the x cut score down on the axis. All right, so again, depending on whether you have the older operating system or the newer operating system, again, either way, you're going to start by hitting second variables and choosing option 3 now for inverse norm. Okay. Again, the area that's asked for is always the area to the left, which is what we were given, was 10%, so 0.10, the mean of 272 and a standard deviation of 9. And then we would highlight paste and hit enter. Otherwise, if you have the older model, it will just say inverse norm and it's blinking at you, waiting for those 3 inputs separated by commas. So you would enter 0.1, 272, 9. Okay, in either case, once we hit enter, we would see this displayed on the output screen. Now this is a value of x, and x is being measured in days. So this is not like 260% chance of something happening. This now is a value of our random variable x, which is measuring the days, the length of a pregnancy in days. Okay. Again, the StatCrunch input screens are here, but again, we are going to mainly focus on using the calculator in these sections. All right, so what this number means, I'm going to actually use the StatCrunch graph that's given here to display that information. But this area in this tail is 10%, and so what we were after was this cut score here, which is actually the 10th percentile. Okay, so that value of x that we were after is 10% of the way into the distribution. And from our computation, we know that that number is a little bit bigger than 260. It's about 260.5 days as we're looking at it there. All right, so just as with percentiles, we don't say 10% are at that particular value, but at or below. Okay, or in this case, we were looking at strictly less than because it's a continuous random variable and the area at the endpoint doesn't matter. So in this case, we can say 10% of all pregnancies, human pregnancies, last less than about 260.5 days. All right, so the last part to this very long problem. So suppose you meet a woman who says that she was pregnant for less than 250 days. Would this be unusual, and what might you think? So would this be unusual? So we would want the probability that x is less than 250 days, which again for continuous random variables also the probability that x is less than or equal to 250 days. And from part C, so I'm just going to put above this equal sign, back in part C we actually computed that probability and we got that to be about 0.0073. So again, whether something is unusual or not, we're trying to see is that less than or equal to 0.05 or is it greater than 0.05? And that probability is definitely less than or equal to 5%. Okay, so since this probability is less than or equal to 0.05, it would be unusual for a pregnancy to last less than 250 days. All right, so that's not to say that she couldn't have had a pregnancy that lasted less than 250 days, because this probability tells us that about 7 out of every 1,000 pregnancies do go less than 250 days. So, it could be that, maybe, baby was born premature, too early, so that's why it was less than 250, or maybe she is mistaken about when she got pregnant.